Hey everyone, in this video we are going to solve the find eventual save states question on Leetcode. It is a graph problem. So we are given an adjacency list. So the array at index 0 represent the nodes the to which node 0 is connected to. So at index 0 we have an array of 1 and 2. So that means node 0 is connected to node 1 and node 2 and so on. And what we are asked to do is to find all the safe nodes. But before knowing what a safe node is, we must know what a terminal node is. And a terminal node is a node that has no outgoing edges. So it has all the incoming edges, but no, it may have the incoming edges, but no outgoing edges. And a node is considered a safe node if all the possible paths, remember here, all the possible paths, not a single path, all the possible paths lead to a terminal node or another safe node. If all the paths meets this criteria, that then the node is considered as a safe node. And at the end we have to return an array of all the safe nodes present in the graph in the ascending order. So this is the question. Let's see how we can do it. Okay, so we have already solved a question on detecting a cycle on a graph in code schedule question. There we used two things. We used a recursion tag and a visited array. So we could use the same solution here, but in some sort of a variation, because in this particular case we just don't have to check if the cycle is present in a graph or not. We have to check all the possible paths and if they are leading to a terminal node or not. So keeping a visited array and adding the current node, each of the node to the visited array will not work in this scenario. So we have to use some other solution. We'll use the DFS, but not the previous one. We'll use some variation of it. So we'll use a map data structure, or you can call it an object literal in JavaScript. And what we'll do, we'll run a for loop from 0 to 6, since there are 0 to 6 nodes in this graph. And for each node, we'll run a DFS function. And if that DFS function returns us true, that means we reach to a terminal node. And if that DFS function returns us false, that means there was a cycle present and we couldn't reach to a terminal node. So how we'll do that, let's see. So let's run it by example. So we'll start from node 0 and initially we'll mark it as false. So we'll consider that initially there is a cycle present from 0 to 4 and keep moving forward from one node to another node. And if it leads to a terminal node, we'll update this value from false to true. Otherwise we'll keep it as false. So from 0, what are the options? What nodes we can go to? We have two options. Either we can take path to node 1, or either we can take to path node 2. So let's take, so since we are running DFS, so first we'll go to node 1 and we'll mark it as false as well. We'll consider that, hey, node 1 consider cycle as well. Then we'll run DFS on node 1. So what are the options from node 1? Where can we go? We have two options. Either we can go to node 2 or we can go to node 3. So we'll go to node 2 first and mark it as false. Similarly, we run DFS on node 2. From node 2, where can we go? We can go to node 5. Then we'll run DFS on 5, mark it as false initially. Then from 5, are there any further nodes from 5 where we can go? No, we cannot. There are no outgoing edges from 5. So that means 5 is a terminal node and we can change its value from false to true and return true from our DFS function for node 5. So 5 for node 5, it will return us true. And let's say we have a result array, and in that result array, we'll add 5. Then for node 2, the output was 5. The output was true. And are there any other path from node 2 where we can go? No, there is only one path from node 2 to node 5 and it returns us true. So if that is the only path and it returns us true and it leads to a terminal node, that means 2 is also a safe node. So we'll mark true 2 as true as well. and we'll return it from our DFS function, and we'll add 2 to our result array. Next, we get to node 3. So is node 3 in our map data structure? Not yet. So we'll add 3 and mark it as false initially. And from node 3, where we can go? We can go to node 0, and node 0 is present in our map data structure and its value is false. And when this case happens, that we reach to a node that is already present in our map data structure, we'll just return that value. So for 0 it was false, so we'll return false, and we'll not add 3 to our result array since it leads to a cycle. Now for node 1, as you can see, one path lead to a terminal node, but another path lead to a cycle. And the question says clearly that a node is considered a safe node when all of the paths return us lead to a terminal node. But in this case, only one path lead us to a terminal node. So one will also be marked as false, since there was one path that lead to a cycle, and will not add to a result array. Going back to node 0, so for node 0, one of the path return as false. Okay, let's see for path 2. So for path 2, we have it is already present in our map data structure and its value is true. So for 2, we return true. So for 0 as well, one path lead to a terminal node and one path lead to a cycle. So 0 is also not a safe node, since all of the paths doesn't lead to a terminal node. So this one is also completed. So initially we start from 0. Let's see for 1. 1 is also present in our map data structure. We covered it. For 2, we also covered it. For 3, we also covered it. For 4, let's say, let's see. So 4 is not present in our map data structure. We'll run DFS on 4. From 4, where can we go? We can only go to node 5. Is node 5 already present in our map data structure? Yes, it is present, and it returns a true. And all the paths from node 4 returns as true. It leads to a terminal node. All paths from 4 leads to a terminal node. That means 4 is also a safe node. So we'll mark 4 as true and push it to our result array. Okay, then for 4 is also completed. Then we go to node 5. It is already present in our map data structure. It returns true. Then we go to node 6. It's not present in our map data structure, and we mark it as initially false. So initially 6 will be marked as false. Then we'll check, are there any nodes from node 6 where we can go? No, there are not. So we'll change it to true, and we'll return true from our DFS function. And since it returns as a true, so 6 will also be added to our result array. And finally we have loop. We traverse through all the nodes from 0 to 6, and this is the result we got, and we'll return this result. So the time complexity for this solution will be O of v plus e. V is the number of vertices, e is the number of edges, and space complexity will be O of v, since we are storing all of these vertices in a map data structure. So this is the drawing explanation. Let's see how we can do it in code. Okay, so first let's declare our variables. So first declare our result array and our map data structure. So map equals to new map. You can use object literal as well. Map just handles some edge cases for us, like if the value doesn't exist or not. So next what we'll do, we'll run a for loop. So let I equals to 0, I is less than graph dot length and I plus plus. So we'll run a loop from 0 to 6. Next we'll check if the DFS function returns us true, and to that DFS function we'll pass the graph, the current node, and the map data structure. And if that returns us true, we'll just push the result to our result array, and that will be our current node. And at the end we'll just return the result array. Now next let's define the DFS function. So it will be a function and it will take three things: the graph, the current node, and the map data structure. Next, we'll check if the value is already present in our map. So if map dot has node, if it is already present, then we'll just return it. So for that we'll add map dot get and the key. The key is node, and we'll get the value for key node. Next, initially we'll set as for node as false. We'll initially consider that it has a cycle, and then we'll check if it actually has a cycle or not. And if it doesn't, then and if all the paths from for this node leads to a terminal node, then we'll just replace this false with true. So we'll run it. We'll run DFS on all of its neighbor nodes. So for let neighbor node of graph add node. So we'll check. So for if not of DFS of graph, in this time the node is the neighbor node and the map data structure. If any of these neighbor nodes return us false, that means we'll just return false. We found a cycle, and this one, so one of the paths returns a cycle. That means we cannot consider this one node, and we'll just return false from here. But if we didn't found a cycle, we'll update the value for this node. So we'll update it from false to true, and at the end we'll return true from our DFS function. So this is the code. Let's run it. Working. Let's submit it. Cool. So that was it for this video. Thank you for watching.